We are Group 6 from Section 3. Today, we would like to discuss about the material selection and process selection for biomedical surgical implant. The title that we chose is Elbow Replacement. Biomedical surgical implant is a medical device that manufactured to replace a missing biological structure and support a damaged biological structure. The elbow replacement is one of the biomedical surgical implants. It can help to reduce pain and help your elbow work better. This is the figure of elbow replacement. The first step of material selection strategy is translation of design requirement. The function of elbow replacement is to reduce pain and help your elbow work better. The constraint is lightweight to reduce pressure exerted on user hand, high tensile strength for bone structural support, high fracture toughness to decrease the incidence of wear in plant material, high modulus elasticity to ensure more uniform distribution of stress at implant and to minimize relative movement at implant-bone interface. The objective is minimize cost, and maximize tensile strength. The free variable is choice of material. The second step of material selection strategy is screening. By using CAS software, we plot a graph, tensile strength versus density. The graph shows the top 5 materials with higher performance index, which is rod magnesium alloy, edge hardening rod aluminum alloy, titanium alloy, nickel-based superalloy, and tungsten alloy. After that, screening using constraint. After eliminated tungsten alloy and nickel-based superalloy, there are 3 material candidates left, which is titanium alloy, rod magnesium alloy, and edge hardening rod aluminum alloy. The table shows the performance for material candidates based on their constraint. The third step of material selection strategy is ranking. As you can see, titanium alloy has the highest ranking, which is 10, followed by edge hardening rod aluminum alloy, which is 8, and lastly nickel-based alloy, which is 6. This means that titanium alloy is the most suitable material for elbow replacement. The last step is documentation seeking. It is used to support the information for material candidates. First, titanium alloy. Titanium has outstanding corrosion resistance to seawater and thus is used in propeller shaft, rigging, and other parts of boat that are exposed to seawater. Due to their high tensile strength to density ratio, high corrosion resistance, and ability to withstand high temperature without cracking, titanium alloy are used in aircraft, armor plating, naval ship, spacecraft, and missiles. For rod magnesium alloy are of special interest as lightweight structural components as a result of their more homogeneous microstructure and improved mechanical properties compared to cast components. Their application is automotive, aerospace, industrial, and commercial application. For edge hardening rod aluminum alloy, the high-strength aluminum alloy depends on edge hardening. Application of edge hardening rod aluminum alloy is aerospace structure, pressure vessel, ultralight lander-based transport system, sport equipment such as golf club and bicycle.
My name is Nohoriha Emilia binti Muhammad Hori. Okay, after the material selection, we do the process selection. First of all, we do the translation process, and this is the translation process that will list all of the function, constraint, objective, and free variables. The function is to reduce pain and help your elbow work better. This is the constraint, the objective, and the free variables to choose of process and process operating condition. After the translation process, we do the screening process, which that we list out a few of processes that can manufacture the titanium alloy. At the same time, in screening process, we find out all of the characteristics of each process from the CES EduPack. So there are what we got from the CES software. Next, we move to the ranking process. So for the ranking, we choose the best 3 of the process that list in screening process before. So we got investment casting, forgain, and ship forming. In this ranking process, we rank 1 to 3 from its properties, which that from the worst to the best. For example, for the titanium alloy, we want the low mass range. Therefore, we look at the screening process. The lowest is investment casting, so it rank with 3, and the highest mass range is ship forming, so it rank with 1. And the ranking process performed for the next table is the same. And for the double confirmation, we do the economic attributes of the process. So the information in this table also we got from the CES software. In conclusion, due to the highest ranking in ranking process, we conclude that the investment casting process is the best process for the titanium alloy. At the same time, the investment casting has the tight dimensional tolerance, which that the tolerance is very important in elbow implant. In addition, the also advantage of the investment casting is it has low waste material process, so it's better for our environment. And lastly is the process was chosen due to only investment casting process is the only metal casting process that can be produced complicated shape in high temperature alloy to a very quality standard. Okay, for it's done for the process selection. And
Assalamualaikum. My name is Muhammad Rayman bin Jamal Wilil. I am from section 3, group 2, and for this assignment I from group 6. And today I'm gonna explain about the process to make titanium alloy for surgical implant.
The first process is selective laser melting. This device consists of laser insulator, a scanning mirror, blade, powder supply platform, and a building platform. First thing we need to do is construct the 3D design model using CAD software and compute it to the device. After the device slice the data and the parameter is set up, put metal powder into the supply platform. After that, the device will scanning the speed, the laser scanning interval, and hash angle. And after that, the nitrate gas or argon gas will introduce into the device. After the appropriate volume gas is loaded, an amount of metal powder suitable for one layer is deposited onto the base plate using a blade. The laser which is emitted from the laser insulator is then reflected by a scanning mirror and irradiated onto the thinly paved metal powder layer. Based on the sliced data, the laser is scanned by controlling the scanning mirror and the metal powder is melted and solidified into the desired shape. Once one layer of the model is complete, the building platform descends by one layer and another layer of metal powder is deposited by using the blade. A metal product with a shape similar to that the 3D design is molded daily by sequentially and repeatedly melting, solidifying, and depositing metallic powder. The other process to make titanium alloy is investment casting. First thing we need to do is create wax pattern using 3D design model with AutoCAD, and then the wax pattern are assembled onto runners and into a finished tree which is ready to be tipped. And then after the slurry coating is done, particles of sand are dropped onto the surface of the wet tree assembly. This helps to thicken and strengthen the layer of coating on the wax assembly surface. And then the waxing, which is the wax inside the newly built shell is now removed. The waxing is done using steam dewaxing, autoclave or flash fire furnace. Now the desired molten metal is poured into the preheated mold cavity and then cooling process. After that, the shell material is then removed through the process hammer knockout, vibration and steel grit blasting. And then for the finishing process is grinding, sandblasting and coating to achieve the final surface needed. And once the finished operation are done, the parts are inspected for surface and subsurface defect. Visual and fluorescent penetrant inspection is done for surface and X-ray is employed for subsurface defect identification.
And that's all from me. And for the next session, I will pass it to my teammate. And remember, during this pandemic, please stay.
Hi and Assalamualaikum. My name is Nur Fakia Imai binti Abdul Kalam Muzakkar, and today I will present about two topics, which are effects of parameters and the second is testing and quality controls. There are several parameters were taken into consideration, and the first one is density. The weight of total elbow replacement should not restrict the user's movement. Thus, a material with low density is needed. The second parameter is tensile strength. A material with high tensile strength is needed to prevent a failure to the product. The third parameter is shape. In this product, a 3D hollow shape is desired and it must be compatible with the selected material process. From this picture, investment casting process can be used to produce a 3D hollow shape. The next parameter is corrosion. The selected material should have a high corrosion resistance, as corrosives from the material can cause a health problem towards the user. The fifth parameter is impact strength. Impact strength for this product must be high to provide a user a protection from a shock wave. The next parameter is conductivity. This product should have a high conductivity material to allow it to regenerate tissues and organs. The last parameter is biocompatible. The selected material should not be harmful or toxic towards the user, as it will cause an inflammatory response or the removal of the implant. We are done with effects of parameters. Let's move to the testing and quality control. The standard specification for total elbow replacement is ASTM F2887. The specification is intended to provide basic descriptions of material and prosthesis geometry. To make sure the implant is working well, a few testing need to be done. The first test is joint stability test. The test protocol consists of VB rotation of the ulna about a fixed humeral component. It is oriented at 90-degree flexion and unconstrained in the Z translation, with the motion terminated at 50 degrees of rotation. An axial load of 10 Newton, 40 Newton, and 90 Newton is applied, and the maximum torque and corresponding displacement can be recorded. The next test is strain test. A strain gauge is placed on medial, lateral, anterior, and posterior cortex of both the ulna and the humerus, and strain is measured while applying either a 400 Newton or 700 Newton joint reaction force at three different angles, which are 60, 90, and 150 degrees. The third test is VB laxity test. This test is done to imitate active contraction and to apply axial loading to the elbow joint. A 20 Newton and 10 Newton force are applied to the triceps, biceps, and brachial muscles, respectively, to imitate active contraction and to apply axial loading to the elbow joint. Next is method for testing corrosion resistance of metal part. The product should be sprayed with natrium chloride distilled water for 24 hours at room temperature and be washed with water to inspect for any corrosion. The next test is fatigue test. Fatigue test can be done by applying cyclic axial torsion for 200 cycles, and torsional stiffness can be calculated between the 10th and final cycle. Bone mineral density (BMD) measurements can also be made and correlated to the torsion results. The last test is biocompatibility test. A small devices or powders could be placed on the agar, and the presence of a zone of inhibition of cell growth could be examined.
To talk about the type of defect of a surgical implant. So the first one is metal hypersensitive. This is a reaction, a biological reaction when happens when a patient goes through a surgery where they have installed an implant into their body, which is most commonly at their joints or at their spinal cord. This reaction is very common, but it sometimes goes to a very hypersensitivity stage where rashes, swelling, burning sensation, or even pain is felt or is present at the point of where the implant is located. This is not strange, but because it is a human response. However, the results of the response can be very severe, such as rashes, severe pain, swelling, because of the metal body's human response towards the presence of metal in their body. Other than that, accelerated corrosion is also another defect due to surgical implant. The presence of corrosive species like hydrogen, chloride, ions, and even titanium ion could be present in the blood. This is because cellular serum, because titanium ion can bind to cellular and human protein. This creates an antigen that elicits the immune response. However, this is on purpose is to avoid or minimize the immune system's attack towards the implant. However, this can cause major complications on the long term. And the most feared defect of a surgical implant is metal debris, where tiny flakes of metal chips from the implants chip off and enter the bloodstream and into nearby soft tissues and joints. These debris happen when force and pressure is exerted on the implant, where when the implants are rubbing each other at the surface. This phenomenon is called fritting, and this metal debris or tiny flakes can end up causing damage to your kidney, your brain, your heart, and even your liver. So, what are the countermeasures to avoid this defect? Is by using biomaterial replacements. Metal, polymers, ceramics can be used as orthopedic biomaterials, as these biomaterials have a less production cost compared to cobalt chromium alloy or titanium alloy, which is much more difficult to fabricate and have a higher production cost. Because the more polymer-based composites have greater fatigue resistance than other materials, and also have high strength and low stiffness. This is great, especially when these joints are required at the knee, at the hip, or even at the shoulder, where a lot of movement is required. And clearly, you do not want a stiff joint, as it will limit your daily movement. So this composite shows a potential viable option and can lessen the influence of stress shielding effect of fritting, as was already previously said in the earlier slide, and cause less damage. Also, bioceramic implants are a huge step in engineering, as bone tissues are taken from the patients and implants are engineered specifically for those patients and composed by itself. However, this option is not widely used. It's not only costly, but it's also used as an internal fixation device, meaning the implants are used to overcome injuries that are internal, not external, such as anterior cruciate ligament injuries or ACL, which is very common among footballers or athletes that injure their knee or, or their shoulder. This implant is very useful. So, in conclusion to all this, is that the whole research purpose of this research or this assignment is to study the process material used to create surgical implant, which is titanium alloy, and the materials that are available to replace this alloy. As current research around the world are being conducted to replace the aluminum titanium alloy in surgical implant, and amazing results, not amazing, but promising results been shown, have been visible currently. With that, quality and control cells are being conducted to make sure these experimental materials meet the current market needed, both by the producers, the manufacturers, the suppliers, and at the end, the patients who will be using this implant. Defects and countermeasures are being researched because these will create new answers and even newer solutions in the medical world, which not only will save lives but also improve the current human limitation joints that are available and may even be no different than the natural bone joints that are currently in our body. With that, that ends my presentation.